Hello and welcome back to the Mate update from the TowNet team. You're here, Bifola, and it's a development update. So over to you, Karim, for your overview this month.
Thank you, Fola, and welcome everyone to the Tau team development update for the month of May. Andrei, from his side, has made two major improvements to the testnet. First, he finished a major task that has to do with replacing the old scripts that we used to run manually to manage the nodes. He replaced those with what he calls Tau Testnet Developer CLI. And so now all node management, key management, and voting can be done through a much more cleaner and robust tool that is the TauNet CLI. But the second milestone that Andrei has achieved is much more exciting. So he switched basically the TauNet consensus that used to be implemented in Python. He switched it to a consensus mechanism that is Tau-driven. And the advantage of that is, as many of you know, that users can submit new rules that can be made part of the consensus and thus updating the consensus mechanism. And this is really the core feature of Tau, that it can be updated by its users as part of the regular block-to-block progression. We'll hear more from Andrei and Ohad on that later in the call. David, from his side, has made a series of improvements focused on reliability and maintainability of the Tau system. Some of these activities included enforcing mandatory bitwidth specifications for types, which enhances the safety and predictability of Bitvector operation. It also allows further simplification of the Tau system logic. He also enhanced Bitvector handling. For example, he made multiple fixes and improvements to the Bitvector operations, including bug fixes for division and modulo operations by zero. He also made enhancements to Bitvector simplification logic and addition and new tests, and added new test cases to ensure correctness of all these operations. He also refactored the code based on he refactored the code base and updated the documentations to improve clarity and maintainability, especially in the predicate blasting and type interface module. On the platform side, David made several improvements to the build process on macOS, making it easier to build and debug Tau on Mac. Then he made a few contributions to the testing and benchmarking side, where he added test fixtures to the benchmarking tools for predicate blasting features. And some ongoing tasks that he continues to work on have to do with adding a cast operator to the bitvectors, and some more improvements to the predicate blasting algorithm and type interface. Lucca, from his side, has been working with Ohad as usual on the algorithmic side, so picking up Ohad's latest algorithmic inventions and turning them into C++ code. In particular, this month he's been working on the implementation of Quantifier block-focused normalization algorithm, which essentially puts together all the lessons that we've learned from working on optimizations during the past few months. Last but not least, Tomáš finished debugging the Tau multi-line parsing issues that were plaguing us the last month. And he did that by postponing the type inference and type definitions till the end of the parsing pass. Then he worked on adding benchmarking code to the Tau API. So any code that calls the Tau API basically get benchmarking support. So we keep track of the performance of all Tau code. And by the same token, when he was in there, he added error handling to all of the API calls as well. Then on the parser side, he fixed the handling of UTF-8 and Windows Unicode and UTF-16 codec. Finally, he fixed a bug in the parse tree generation where some nodes were not being reused. That's it for the Tau team this month. Back to you, Fola.
Awesome stuff. Thank you, Karim. I'll pass it over to you, Tomáš, for your update this month.
Thank you, Fola. Hello, everyone. This month, I've been working on merging my changes of Tau spec multi-line parsing with postponed type inference of definitions. Then I was working on API improvements, mostly regarding error handling and benchmarking. We introduce a new Tau result and template, which works as C++ own std expected type, but it also contains non-error diagnostic messages like warnings and informational messages. Then I've enhanced parser for UTF-16 codec and conversion to Windows white strings. So the parser and the TGF tool both now support Unicode. Then I fixed bug in getH function of the tree library, which was not reusing existing nodes. This function is used for nodes we want to keep alive for long-lived objects. And then I spent some time on identifying those long-lived objects in Tau engine, so we can start using garbage collection so we don't outgrow the memory. And that's all from me for this month. Thank you for your time.
All right, fantastic. Thank you, Tomáš. Over to you, Lucca, for a deeper dive.
Thank you, Fola, and thank you for joining, everyone. So as Karim mentioned, this month I've been focused on implementing optimizations for the current normalization algorithm. The main idea is to basically enable early simplifications as much as possible in combination with as little traversals as possible through going through the formula in all the normalization process. And one of the ideas is, for example, to eliminate quantifiers in one pass as much as possible using a BDD library. And it turned out that to do this in a non-lazy way, the non-lazy approach basically naturally leads to a block-focused elimination algorithm, because if you have several quantifier blocks, the way that these quantifiers basically get pushed into atomic formulas results such that you have only a non-lazy BDD if you don't have too many block alternations in some sense. And for this reason, we get a block-focused algorithm to do as little lazy work as possible. Lazy in this case means to basically have a syntactic representation that needs to be normalized at a later point, making these early detections in some sense not completely possible because things are not normalized at this stage. Yeah, just to give a short glimpse to the underlying ideas. I hope you enjoyed it. Back to you, Fola. Thank you.
Great stuff, Lucca. Thank you very much. And I'll pass it over to you, David. Cheers.
Thank you, Fola, and hi, everyone. During this month, I have made several improvements and also focused on the maintainability and the performance of the Tau code base. In particular, I have enforced mandatory bitwidth specification for types, which increase the safety and the predictability of Bitvector operations, and also allow further simplification of the type system logic. I have made several enhancements to Bitvector handling. In particular, multiple fixes and improvements were made to Bitvector operations, including some bug fixes related to division and modulo operations by zero. Enhancements in the Bitvector simplification logic, and also I have had a lot of new tests to ensure correctness. I have also do some refactoring and documentation tasks related mostly to predicate blasting and also the type inference modules. I have had in particular a lot of Doxygen documentation to help further contributors understand the code. Regarding ongoing tasks, I'm adding a gas operator for Bitvectors. The grammar support and the basic type inference are ready. Several improvements in predicate blasting and in the type inference module are needed, and also test everything properly. And also I have made several changes into the testing benchmark module. Now we are able to run fixtures that correspond to clear script. Also, I have done several minor changes in this module. And that's all for my month. Thank you all for listening. Back to you, Fola.
All right, fantastic. Thanks, David. And over to you, Andrei.
Hello, everyone. This is my monthly update on Tau testnet alpha development. This month I took some massive steps in both our core architecture and developer experience. My primary focus this month, of course, was Tau-driven consensus mechanism migration. For this, I stripped the Python code of the consensus code, and now consensus lives in the blockchain, in the Tau state, governed by on-chain revisions. Of course, to support it, I had to add new type of transactions. Now we have a transaction to propose, a dedicated transaction to propose a new consensus rule, and a transaction to vote for the proposal. So basically now you can view active consensus rules, propose consensus improvements, updates from the templates, and vote for them directly from your web wallet UI. Also, to make the Tau testnet development less frictionless, I made a new polished, easily installable tool, so you don't have to juggle various Python scripts and Docker commands, and now everything is within one place, one single command that lets you do all the necessary stuff, including, of course, node management, running your local node, like running your isolated local node, and testing whatever you need. So it's been very productive months, and to support it, I created a swarm of blockchain agents. That right now live only on my local host, on my isolated node. They communicate with the blockchain. They send transactions to each other. They figure out and propose various rules and consensus rules. They vote for consensus rules. So they basically trying to use all the capabilities that Tau testnet provides. And it gave me a lot of food, not only in terms of bug tracking, but also in a way that we can improve the testnet. And I hope I will release this swarm soon, so those agents will live on the blockchain alongside all of us. So we will see where it will bring us. Thank you for your continued support and enthusiasm, and see you next month.
Awesome. Thank you very much, Andrei. And last but never least, as always, Ohad, over to you.
Yeah, so as you know, I've been working on the algorithm and the paper for the temporal extensions of the Tau language to support at least parts of LTL, and I realized that the approach I was trying was completely wrong. So I looked for a new approach, and I found one, and it was very successful. It is much cleaner, and it does more than I expected. It can support full LTL. It's algorithmically much easier. And I wrote a paper. That's very nice improvement. And then another major thing that happened is that I tried to give it to LLM agents to implement over the code base of the Tau language, and they seem to manage to do it. We still didn't put this code on the main Tau language repo, but it looks like very nice progress, so we can make the features available much sooner than we would normally expect.
That's a mic drop from Ohad. Thank you very much, everyone. And yeah, we'll see you on the next one. Our socials, as always, Tau_net on Twitter or X, TauNet AGRS, that's our subreddit, and TauNet, all one word, that's us on Telegram. Thank you very much. Cheers. Bye.